Let's solve a very interesting question of coordination compound, and the question is a complex of cobalt plus 3 having molecular formula CoCl₃ xNH₃. When dissolved in water, 3 ions are produced. The number of chlorine negative ions satisfying both primary and secondary valency is. Okay, this is a very good level question, or this question from Werner theory. Okay, so see, complex of cobalt, that cobalt here oxidation state is plus 3. Okay, so CoCl₃ xNH₃, if you form that coordination complex from here, then you have to form like this: CONH3 X Cl, and if you put outside 2 chlorine and inside 1 chlorine, here this compound can possible, right? Another compound also possible, like for oxidation state plus 3, 3Cl also, that is also possibility. But here this information, very important information here, that is we have to form the coordination compound in such a way that 3 ions should be produced. That means here if you dissolve this coordination complex, then it will produce 4 ions. Here 3 chlorine and 1 complex ion, that is total 4 ions. But here if you put outside 2 chlorine and inside 1 chlorine, then these total ions will be here 3 ions due to 2 chlorine, that is counter ions, and 1 complex ion. So total will be 3 ions. So this is your final complex. Then in cobalt plus 3 oxidation state, coordination number you have to maintain, that is 6. That's why this x is nothing but 5 only. If x is 5, that means NH3 5 times and chlorine 1 time. Okay, so coordination 6 also maintained, and now outside 2 chlorine is there. Okay, so the question is the number of chlorine ions satisfying both primary and secondary valency, both primary and secondary. So if you calculate here oxidation state, so cobalt X for NH3, that is neutral ligand 0, 0 into 5, plus chlorine, that is minus 1, and for outside chlorine that will be minus 2, that is equal, total charge should be 0 here, right? So implies that X will be equal to like plus 3, right? Plus 3. So here in calculation of oxidation state also this chlorine involved. Okay, so and in coordination number also total that coordination number is 6, and in that 6 also this chlorine involved. Primary valency is what? Oxidation state. So in oxidation state also this chlorine involved. Also in secondary valency, that is coordination number. So in coordination number also this chlorine involved. That's why the number of chlorine ions satisfying both primary and secondary valencies is only one chlorine, that is inside present. So answer will be B option.